Hello, my dear student. How are you? Welcome to my channel. I hope you are all will be fine. I'm also fine. Thank you. What is the position? What is the situation there right now? Please comment me. Okay, thank you. Let's start today topic. Today topic is definition. Today topic is about free radical. What is free radical? What is mean by free radical? And today lecture we will be study about the definition of free radical, structure of free radical, formation of free radical, stability of free radical, and reactivity of free radical. These all things will be classified. These all things will be explained today in this lecture. So let's start. First of all, definition of a free radical. Are you ready? I'm ready. Are you ready? Okay. Chemical species. Those chemical species having one or more unpaired electron are called free radical. Those species having one or more unpaired unpaired electrons are called free radical. Free radical. Those chemical species having one or more unpaired electrons are called free radical. What is meant by unpaired electron? Unpaired electron mean that is single electron. Electron pair is only present when double electron. When there is double electron in single orbit having opposite spin will be called a paired electron, while unpaired electron has single electron in any orbit is called unsingle unpaired electron. So those species that have any single electron in any orbital in any degenerate orbital is called are called free radical. For example, let's suppose that is hydrogen having one electron present, and the electron will be present, free radical will be present from the dot on uh, the upper surface, on the upper position, on the upper part of the compound atom that have free radical, that have unpaired electron. So that is one hydrogen is like that. That is hydrogen. This is one orbital of hydrogen. This is the nucleus of. So here in this orbital, this is s orbital. Not s orbital is not like that. Sorry, s orbital will be spherical. So if the this is h, if electron is present, one electron is present here, this will be called will be called free radical. If this is carbon, CH3 having one orbital containing one unpaired electron, this unpaired electron is called, this species is called free radical. What is this? This is free radical. Very simple. C2H5 data, this is free radical. C6H5, C6H5 data, this is free radical. Yeah, these all are free radical. If you have any question, you can ask me in comment section. I will reply quickly. Okay, let's proceed further. This is the structure of free radical. Yeah, this is the structure of free radical. Have orbital having one lone pair, one electron pair. Only one single electron is present in one orbital will be considered as free radical. Is it clear? Okay, let's start further. So how the formation of free radical occur? Formation of free radical occur. Formation of free radical is the product of homolytic fission reaction. Homolytic fission reaction. homolytic bond fission. It will leads to the formation of free radical. It cause the formation of free radical. Yeah, this is cause the formation of free radical. Let's suppose this is one hydrogen, this is another hydrogen, this is the bond. You know, each bond, every bond in the chemistry, either inorganic, organic, analytical, which chemistry, every bond, this is inorganic bond or organic bond, each compound, each bond contain only two electrons. There is some bond, there is some also some exception cases where three bond exist in three bond exists in single bond, where three electron exist in bond. Also there is some cases where one electron exists in single bond, like in B2H6. Yeah, this can, but in 90% up to 99% cases, here is every bond contain two electrons. So this bond have also one electron from this hydrogen, one electron from this hydrogen, means covalent bond, the single covalent bond is found. So when they are homolytically fusion, homolytically mean homo means same, lytic means fusion, lytic mean breaking. When the bond is breaking same, when the bond is breaking likely, means one electron go here and one electron go here, the product will be free radical. One electron will be here, one electron will be there. This is the formation of free radical. Like this is CH3H, this is CH4 methane. If this bond is homolytically fusion, what will be happen? It will cause free radical. Yeah, let's suppose this is Cl2. If the bond is breaking homolytically, what will happen? Free radical will happen. Yeah, you have any question? Very simple. Okay, let's start to the stability and the reactivity of a free radical. You can take screenshot or you can rewind the video. So, what is the stability and reactivity of the free radical? So, let's start stability and reactivity of the complexes. Let's take any example. The example is like, here is CH3 free radical, here is primary methyl radical, here is secondary CCH3 radical, here is CH3CCH3CH3 radical, tertiary radical, secondary radical, primary radical, and methyl radical. What will be the stability and reactivity order in this compound? Okay, let's start. Are you ready? Okay, this is one diagram. Here, in case of here is one phenomena involved, which is called hyperconjugation. I will take another lecture what is meant by hyperconjugation. After the class, I will put the links of hyperconjugation in this lecture description box. Then you can watch the hyperconjugation topic from the link that I put in this here in description box. Okay, hyperconjugation is the phenomena in which a sigma bond of in hyperconjugation there must be hydrogen present. It is condition for hyperconjugation. Hydrogen must be present, hydrogen must be present in organic chemistry. The sigma bond of hydrogen will partially will partially convert into or delocalize with the or with or in delocalization partially convert into partial pi band, partially convert partial sigma band convert into partial pi band, partial pi band. It mean that it mean that sigma bond, it mean that sigma bond will be partial sigma band, partial sigma band will be in delocalization with partial pi band, partial pi band. So it will be like that. So similarly here in this case, for example, let's take one example of this. After that you will be get my points easily. Let's suppose this is methyl ch c ch2. Here is let's suppose here is a plus charge. Let's suppose here is plus charge. If there is one hydrogen, what will happen? This hydrogen, the partial bond, this bond will be shift here. When this partial bond shift here, what will happen? This will be happen like this is Ca2, not like that. This is ch, this is h, this is h. This h will be written because this are with now it is attached with c, so it will be right like this. H have positive charge, but here double bond will be occur, ch2. So that is called hyperconjugation. This partial bond, this partial bond, partial pi bond, this partial pi bond can also be converted. So resonance will establish, delocalization will establish. Delocalization between partial sigma bond and partial pi bond will occur. So similarly, this partial bond have more the number of hydrogen. It means that more the number of hydrogen, more will be hyperconjugation occur. More the hydrogen, more will be hyperconjugation, more will be hyperconjugation. Is that clear? Hyperconjugation is similarly resonance. It also gives stability up to some extent to the given complex, to the even complex that have resonance, that have hyperconjugation, that have delocalization between partial sigma bond and partial pi bond. Is it clear? So here in prime in tertiary amine in tertiary free radical, it have more number. It has here is 9 hydrogen, here is a 9 hydrogen present. So these all hydrogen can take part in hyperconjugation, means more will be hyperconjugation occur. More the number of hydrogen, more will be hyperconjugation occur. When more the hyperconjugation occur, more will be stability occur here. But in case of secondary free radical, here is only 7 hydrogen. So here is a very less, very less. Here is not only 7 hydrogen, because this is hydrogen that is not only alpha hydrogen is, only alpha hydrogen can take part in hyperconjugation. So here is 6 alpha hydrogen, here is 9 alpha hydrogen, here is 6 alpha hydrogen. 6 alpha hydrogen will have show hyperconjugation and show stability, but it will be less than tertiary free radical. But it will be the secondary free radical stability will be more than primary free radical, while this stability, free radical, this stability will be more than the methyl radical. It mean that the stability order will be like that, that is stability order. While the reactivity order will be, this is reactivity order. This will show more reactivity, this will less reactivity, this will very less, this will very very less reactivity, this is the less reactivity order. These are the concepts of free radical. I hope you will be get very clear. If you have any confusion, if you have any question, if you want more explanation, I will do more. You can ask me, you can put your comments in comment section. Also you can ask me in my personal WhatsApp, in my personal Gmail, that I put in description box. You can take from my description, from that value, that video description box. Also please subscribe my channel. If you like my videos, if you like my teaching method, please subscribe my channel. It make me feel very happy that my students are supporting me. Okay, thank you, best of luck my dear student.